Now chance for you to ask any questions, any scenario that was not clear has to be asked now, please. If you hesitate, I don't know what you're trying to do. Like what part is not clear to you? Ninad, Abhinaya, Grishma, I mean everybody. I cannot take all the names here, but Abhiraj, Atri, Grishma, Abhinaya, Emma, Sheikh Manjushri, Mrunal, Sinha, Ninad, Rhythm, Rukaya, Sai Kumar, Shivangi, Shreya Bhatt, Shreya Hegde, Trisha and Vasudeva. No questions? सारा clear है, all set? समझ में आ गया? Everything is clear so far? ठीक है, clear है, crystal clear है तो ठीक है. Okay. I keep asking this so that there's no confusion. Now, refractive index you've already covered in grade 10th. We'll cover again. No worries. Right. But look at this. The light actually is slowing down in the water. Right. Light slow हो जाएगी, तो wavelength भी slow हो जाएगी, and then the wave fronts will come closer and closer. Yeah, these are the things I've already covered. I'm going to show you the slides now. I covered them already. So अगर slit है, this is actually where diffraction comes into picture. This is diffraction. So this is actually diffraction. Diffraction क्या है? Bending of light around. So window है, right? यहाँ से आवाज जा रही है, and then the sound is bending. Right? Bending of light will not be visible here because of the size of the window. It's huge. You need a very thin slit there. And this is what this is. So if you look at this, these are plane wave fronts, and this is what we are doing. If I draw in 2 dimensions, the rays of light were coming like this. These are the rays of light. So when they come out, they fan out actually, kind of. This is called fanning, right? Fan ban gaya. And this is diffraction of light. We will study in a lot more detail than this. We are going to do mathematics around this. We have to calculate things here. But this is what is happening, because if you look at this, the wave front is this, perpendicular to that, perpendicular to this, perpendicular to this. So you've converted a plane wave into a cylindrical wave front. This is diffraction of light passing through a slit. पतली सी opening कर दी, right? उसके बीच में से let the light go. Yeah. So Abhiraj, this is not double slit. This is single slit. Yeah, you're right. But this is single slit. है ना? So you wrote YDSE. This is basically single slit. Double slit से interference होगा. Single slit is diffraction. Plane into spherical. अब instead of taking a slit, you take a point. एक paper लिया, paper में छोटा सा like pinhole. You make the pinhole. When the light goes through that, it'll actually. And all this is basically behind the scene is Heisenberg's uncertainty principle. I don't know if I go into that direction and explain you. I will just take 1 minute or less than that. So let's say you have this slit. Okay. Heisenberg's uncertainty principle. What did it say? We studied briefly that you cannot. So uncertainty in momentum and uncertainty in location is constant. Right? That's reduced Planck's constant. ठीक है. अब देखो यहाँ से photons जा रहे हैं. I don't know the location. Photon can be here, anywhere. This photon can be anywhere in the region there. समझ रहे हो? Like what we are saying. So if you don't want to listen to this, that's fine. So for next 2 minutes, don't listen if you don't want to. So there is an uncertainty in location of the photon. I don't know where it is, right? Because uncertainty principle says that. But maybe I try to play smart and make a very thin slit there. So what I'm saying is, if the photon passes through this slit, I have reduced the uncertainty. See how smart I was, right? I'm saying it's somewhere in this zone, but if I put a tiny slit there and if the photon goes right through that, oh, I am so smart that I'm saying, oh, the uncertainty is only the size of that. This is delta x. I was trying to be smart, but nature says, you know, you cannot be smart, because the nature says as soon as you reduce this uncertainty, the momentum uncertainty increases. So what I'm doing is I'm reducing the uncertainty here. Nature says, no, I will increase the uncertainty here. By doing what? By making the photon either go this way or go this way or go this way. Momentum is a vector quantity. I know the speed of the light is fine. I know the mass of this, but then I don't know the direction where it is going. So momentum is somewhere in the bigger range now. The smaller you make the slit, the bigger the fanning out of this. So what you will observe, actually, this is one of the experiments, we'll cover that. If you take a light source here, you will see a very small spot there. You should actually do in your room somewhere. So you take a tiny hole, and then if you throw the light through that, you will see it is point there on the screen. But if you try to reduce this, so this was a light here, right? So originally the light was here, but if you reduce this, you're supposed to assume that the light here will fall in a smaller region, and you will actually see it is going smaller and smaller. But after a certain point, this will start growing here. You're making this slit smaller, but the light will be here. It'll split. Right. Yeah, like a laser, Atri. But if you take a laser and if you make the slit smaller and smaller, instead of that spot on the screen getting smaller, it will actually get bigger and bigger. So that is Heisenberg's uncertainty principle at play. In other words, this is diffraction. Right? Diffraction as in if you reduce the slit size, the light will diffract more. But behind the scenes, it is all this uncertainty principle. Okay? We will do diffraction without understanding uncertainty principle. You don't have to. Any questions so far, please ask me. Any doubts can be asked now. So yeah, this we already covered. In the prism, plane wavefront is getting into plane wavefront, but it's bending. Now in the case of this one, it's getting spherical, right? I think I will have to upload more slides. I have gone a little faster here. ठीक है, clear with this concept, everybody clear? Okay, if nobody is asking doubts, I'm assuming clear, crystal clear, right? This was supposed to be a summary, but then I will have to really upload more slides. Okay, explain converging wavefront. I will do that. Ninad, I will do that. Thank you, Ninad, for being what should I say, confident. Right? This is what you're asking, Ninad, right? Yes, take it. So I will draw my own because that makes more, because we are doing stepwise. Yeah, na? If there is a picture already in there, you get distracted by what is already made, right? Very ugly spherical lens there, but let's say this is a beautiful lens, and then this is a wavefront. Okay, that's another wavefront, right? That's another wavefront. है ना, strike कर गया मेरे को. Yeah, I will. Shreya Bhatt, thank you for asking. I'm taking your name, Shreya Bhatt and Ninad, because I really like the confidence. You should ask in the class. Okay? And if you don't want your name to be taken, when you write the question, you say no name, please, or don't take my name. You type it in bracket there, right? If anybody doesn't want to take the name, please let me know. Okay? I will explain prism after this. Now look at this wavefront. This has already striked here. So this part of the wave front, this part of the wavefront will travel up to here, right? Whatever the distance is in the glass, slow, kind of very slow, right? Compared to the other one. So on the edges here, they will travel so much. They will travel here. This will travel here. है ना? So बीच में कोई है यहाँ पर है blue color बना दें उसको. So this one will be partly in this, partly in this. So maybe it will come here. This one will come here maybe, right? So now if you join all this, you are actually getting a wavefront, right? This. तो वो जो था, that is bending now. So ये this becomes this. So ये जा रहा था and this becomes this. But as a result, if you look at the rays of light, the rays of light were this. I will draw green color light maybe. ठीक है, this is the rays of light. These are the rays of light. है ना? Perpendicular to here, perpendicular here, perpendicular here, perpendicular here. But now when you look here, this is perpendicular. See, curve का perpendicular क्या होता है? Radius. If you don't know that, please make sure you understand now. This is a circle. Now here I have to draw 90 degrees line to this. That is actually the radius. This is 90 degrees line. यहाँ पे बनाना है. This is the 90 degrees line. This is 90. right? So by that logic, this is going to be, the rays are actually going this way now. They're all meeting there. Right? So the rays of light which were parallel, they're converging. Clear now? Any confusion with this lens? Yeah, Shreya, I will explain prism after this. Um, clear na? Clear? Sabko clear? Everybody is clear with this? Nobody is writing anything, so I'm assuming clear.